In this video, we're going to take a look at the chain rule. So we've seen before, using our power rule, that if y is equal to x to the 7, then y prime, the derivative of y with respect to x, would be 7 times x to the 6. But what happens if we had a function y that looked like, say, 2 plus x cubed, all raised to the power 7? In this case, we want to develop a rule that helps us figure out the derivative of y. And we'd like to figure out a rule that works fairly quickly. So to get us going, let's imagine rewriting y as, say, u to the 7. And u will just represent this function that we have inside the brackets here, the 2 plus x cubed. So using our derivative rules, we could say that the derivative of y with respect to u, dy by du, is equal to 7 times u to the 6. And then looking over here at our function u, we can say the derivative of u with respect to x, so du by dx, is equal to 3x squared. Now we can think of dy by dx, the derivative of y with respect to x. We can think of that as dy by du times du by dx. So the reason this makes sense is we could actually think of canceling the du in the denominator here with the du that's in the numerator. So if we were to imagine crossing those out, we'd be left with dy by dx. So this is where the motivation comes from for writing it this way. Now if we look back to our previous line, dy by du was 7u to the 6, and du by dx was equal to 3x squared. So if we rewrite our answer now completely in terms of x, remember that u really was the function 2 plus x cubed. So we could rewrite this as 7 times 2 plus x cubed, all raised to the power 6, and then that's times 3x squared. So this process here is one way of getting the derivative of finding y prime. Now the rule that we used here, back here in this step where we chose to write dy by dx that way, what we're doing here is we're using what's called the chain rule. So the chain rule tells us if y is fairly complicated, as it was in our original problem here, if y is fairly complicated, we can think of rewriting it in terms of another variable u, and then we can think of dy by dx as dy by du times du by dx. Okay, so there's our chain rule. Now often what happens in math is we're presented with a formula like this, and what we really need to work on, what we need to think about is how to make using this formula easier. How can we really figure out the pattern of what our answer is going to look like so that we don't have to do all this work here to get our answer? If we think a little bit about what the pattern is, we should be able to come up with an idea that's going to help us calculate the derivative in basically one line. So let's break down what we did here. We started with a function y, which looked like 2 plus x cubed, all raised to the 7th power. Now we can think of y, this function here, as a composition of functions, meaning there's an inside function. So the inside function is 2 plus x cubed. and then some other operation is being performed on that inside function. So the other operation is the operation that raises a quantity to the 7th power. So this function that raises quantities to the 7th power, that's our outside function. Okay, now using our calculation that we did over here, we should be able to figure out how we get our answer quickly in terms of the inside and the outside function here. So dy by dx is equal to, we know it's supposed to equal 7 times 2 plus x cubed to the 6th power times 3x squared. And let's see if we can describe that in terms of our inside and outside function. Well, this first part here, that looks sort of like the derivative of u to the 7. If we think back here about the substitution that we made, we wrote y as u to the 7. And this first part here corresponds to taking that derivative of y equals u to the 7. So we could say this is the derivative of the outside function. We're taking the derivative of the outside function while leaving the inside function the same. So I don't actually need the equal sign here. Let's describe it in words. It's the derivative, so I'll just write dir for short, derivative of the outside function Okay, and what's really important here is that we're keeping the inside function the same. So that's the first part. Then we multiply by this 3x squared here. Well, 3x squared, that is just the derivative of the inside function. So if we try to describe the chain rule in words, there's 3 parts of the puzzle. The first part, we take the derivative of the outside function while keeping the inside function the same. The second part of the chain rule, just this multiplication sign. So we need to multiply on the derivative of the inside function. So with that figured out, let's see if we can try a quick example, and we're going to aim to write down our answer in one step. So let's try this example here. Let's say y is equal to x to the 5th minus 6x raised to the 4th power. And we're going to find y prime, or the derivative of y with respect to x. Well, we certainly need the chain rule because we've got an inside function here. It's not just a simple x being raised to the 4th power, but it's something more complicated than that. So we're going to use the chain rule to solve the problem. If this x to the 5th minus 6x is our inside function, then this 4th power here, that's our outside function, and that will get us started on doing our derivative. So we're going to take the derivative of the outside function while keeping the inside function the same. The outside function is just the function that raises a quantity to the 4th power. So the derivative is going to look like 4 times our inside function raised to the 3rd power. Okay, and I usually write it like that. I just leave myself the bracket, just think about what the outside function is doing, then I fill in the details of what the inside function looks like. So that's the first part of the chain rule. Then we're going to multiply. So that's the second part there is multiplication. And the third part, let's just multiply now by the derivative of the inside function. So derivative of the inside function, 5x to the 4th minus 6. And we are done. Chain rule in one step. Now we're generally just going to keep our answer factored, so that's a good enough answer for now, and we're done that problem.